ल आज हामी चाहिँ के सिक्छौँ भने जस्तो कि अर्थको रेडियस चेन्ज गरियो भने अर्थको रेडियस चेन्ज गरियो भने अर्थको टाइम पिरियडमा अर्थको टाइम पिरियड द्याट इज द अर्थको रिभोल्युसन एबाउट इट्स अन एक्सिसमा जुन टाइम लाग्छ कम्प्लिट वान रिभोल्युसन एबाउट इट्स अन एक्सिसमा जुन टाइम लाग्छ त्यसलाई हामीले अर्थको टाइम पिरियड भन्छौँ है। वाट डु मिन बाई द टाइम पिरियड अफ द अर्थ? द्याट इज द टाइम टेकन बाई द अर्थ टु कम्प्लिट वान रिभोल्युसन एबाउट इट्स अन एक्सिस। त्यो टाइमलाई हामीले के भन्छौँ? टाइम पिरियड अफ द अर्थ। र त्यो टाइम पिरियड अफ द अर्थ अराउन्ड 24 आवर हुन्छ अर्थको लागि, अराउन्ड 24 आवर हुन्छ है। हो त त्यो टाइम पिरियडको भ्यालुमा के चेन्ज आउने हो? इफ अर्थको रेडियस हामीले चेन्ज गरियो भने विदाउट चेन्जिङ इट्स मास, अर्थको रेडियस हामीले विदाउट चेन्जिङ इट्स मास चेन्ज गरियो भने अर्थको टाइम पिरियडको भ्यालुमा के फरक आउने हो त? हो त्यो डिस्कसन आज गर्छौँ हामीले। हो त यसमा जस्तो कि इनिसियली लेट गरौँ, लेट इनिसियली मास अफ अर्थ m1 m भनौँ र इनिसियली रेडियस r1 r भनौँ, अथवा me भनौँ, मास अफ अर्थ रेडियस अफ अर्थ re भनौँ। र फर्स्ट केसमा यो केस गरौँ। सेकेन्ड केसमा हामीले के लेट गरौँ भने सेकेन्ड केसमा इनिसियली पछाडि सेकेन्ड केस लियौँ। सेकेन्ड केसको मास हामीले m2 me नै राख्यौँ, मिन्स मास चेन्ज गरेनौँ। यो m1 भन्ने मास me हो, अर्थको मास भने m2 भन्ने मास पनि me नै हो। तर रेडियस हामीले r2 भन्ने रेडियस सपोज गरौँ कि r2 अब re/4 अथवा re/6 अथवा re/8 कुनै re/ केही हुनसक्छ। मिन्स अर्थलाई हामीले यहाँ कन्ट्र्याक्ट भएको मान्यौँ। वी हेभ एज्युम्ड हियर द्याट द अर्थ कन्ट्र्याक्ट टु इट्स 1/4 of its radius, or in the another case maybe the earth will contract to to 1/6 of radius. Then in that case r2 will be re/6. If earth has contract to its 1/8 of its radius, then r2 will be in that case re/8. So according to the question r2 will be different, but in this case we have assumed that r2 or the earth has contract to its 1/4 of its radius. So r2 will be re/4. r2 will be re/4. Or in another way we can say that re into 1/4. So re into 1/4 will be re/4. I have written this directly here, but the process is like this: re into 1/4. It means what? It means earth has contract to its 1/4 of its radius. So r2 will be re/4. Now how can we proceed that the time period from here to here, how much the time period will change from here to here? Again, so let again in this case time period of the earth is t1, and this t1 is equals to t. This t1 is equals to t, and in this case let the time period of the earth will be t2, and t2 will be unknown here. t2 will be unknown here, so you have to find this t2. For this type of question, or for this type of question, we proceed through the principle of conservation of angular momentum. Then what do you mean by the principle of conservation of angular momentum? So principle of conservation of angular momentum थाहा हुनु पर्यो है। हो त according to principle of conservation of angular momentum, if torque on a net torque on a system is 0, then the angular momentum of that system remains constant. So we can write here, according to principle of conservation of linear momentum, according to principle of conservation of not linear, angular momentum, according to principle of conservation of, I write the short form here, conservation according to principle of conservation of angular momentum, I1 omega 1 is equals to I2 omega 2. This I1 omega 1 is the angular momentum in the first case and I2 omega 2 be the angular momentum in the second case. While putting the value of I1 omega, now put the value of I1 omega 1 and I2 omega 2. Now putting the value of I1, we know that the earth is nearly a sphere. Earth is nearly a spherical body. So I1, that is the for earth, in first case I1 will be 2 by 5 m times m1 times r1 square. Omega 1 means 2 pi by time period 1. Similarly, in the case of I2, we have 2 by 5 times m2, 2 by 5 m2, 2 by 5 m2, 2 by 5 m2 and r2 square, and omega 2 will be 2 pi by time period, second time period, let t2. Now putting the value of this m1 r1 and m2 r2 and t1, we can calculate the t2. So put from this table, put m1 r1 t1 m2 r2 from this table or from the given information. So again we have one question, why we write 2 by 5 m1 r1 square in the place of I1. सो यो भ्यालु म पहिलेको भिडियोमा डिस्कस गरिदिएको हो कि कुनै पनि स्फेरिकल बडीको लागि मोमेन्ट अफ इनर्सियाको भ्यालु 2 by 5 mr स्क्वायर हुन्छ, 2 by 5 mr स्क्वायर हुन्छ। तर यो 1 किन भएको हो, किनभने यो I1 हो। सो यो फर्स्ट केसमा I1 हो अनि फर्स्ट केसको मास m1 r1 लेख्यौँ, सेकेन्ड केसको मास m2 r2 लेख्यौँ। अब यो भ्यालु राखौँ, 2 by 5 m1 को भ्यालु me हो, r1 को भ्यालु re हो अनि re को स्क्वायर अनि 2 पाई बाई टाइम पिरियड t1 t हो। यतापट्टि 2 by 5 अनि m2 को भ्यालु me हो र r2 को भ्यालु re बाई 4 हो अनि यसको स्क्वायर हो अनि 2 पाई बाई टाइम पिरियड सेकेन्ड, 2 पाई बाई सेकेन्ड टाइम पिरियड। So solving this equation or this equality, we will have 2 pi cancel, 2 by 5 me, 2 by 5 me. So in finally we have re square upon t is equals to re square upon 16t2, 16t2. Where this 16s come from this 4 square. So re square also got cancel and we will have t is equals to 16t2, t is equals to 16t2. Now we will have t2 is equals to, or 16t2 is equals to, interchanging this we will have 16t2 equals to t or 16t2 is equals to t. So writing here 16t2 is equals to t or t2 is equals to t by 16, t by 16. अब यसमा हाम्रो यो t2 मिन्स के हो, टाइम पिरियड इन द सेकेन्ड केस। t2 के हो हाम्रो टाइम पिरियड इन द सेकेन्ड केस। So time period in the second case is what? 1 by 16th part of the time period in the first part. Time period in the second case is what? 1 by 16th of the time period in the first part. This can also be written as 1 by 16 into t, so that we can read 1 by 16th of the time period in the first case. Okay. Again we know that time period of the earth is nearly 24 hours. So putting the t is equals to 24 hour, putting t is equals to 24 hour, we can calculate 3 to that is 1.66 hour, 1.66 hours. No, 8 3 जा and 8 2 जा 1.5 hours 1.5 hours 1.5 hours means time period in the second case will be 1.5 hours. Time period in the second case will be 1.5 hours, or time period in the second case will be 1/16th of the time period in the first case. In this way we can calculate the time period when radius of the earth changes keeping its mass constant. When radius of the earth changes keeping its mass constant. So in the second case we have here second radius is 1/4 of the initial radius. It may be 1/6 of the initial, 1/8 of the initial, no, 2/3 of initial, or 3/4 of the initial, maybe any value, but I have calculated here for 1/4 of this radius. Okay, सो यो भिडियोमा यति नै गरौँ। केही अब यसो छ भने कमेन्ट गरौँ अनि देन त्यो अनुसारले फेरि क्याल्कुलेट गरौँ ल है। ल यो भिडियोमा यति नै राखौँ।